want to make a difference? You can with engineering. Engineers are constantly trying to make our world safer from the hurricanes, tornadoes, and storms that threaten our communities every day. We took 3 kids to Clemson University's Wind and Structural Engineering Research Facility in South Carolina to see how engineers are developing the new tornado-resistant building materials of the future. Come along with us as we discover engineering. Meet Dr. Scott Schiff, professor of civil engineering at Clemson. He and his students run a high-tech research program that specializes in designing and testing these building systems of the future.
Well, when we showed up, they said we were going to be learning something about engineering. And I know nothing about engineering, so I was actually pretty interested to see how the whole day would go.
All I really knew about engineers were that they made things.
Welcome to the wood shop.
Coming into it, I didn't really know exactly what we were planning to do. I knew that it was for engineering, but I wasn't really sure. I thought engineers worked on trains and train tracks, and I was really shocked that they do different studies and experiments, and they can work with lots of different textiles and stuff like that.
Today we're going to learn how to build a tornado shelter using cross-laminated timber. Down here in this tabletop is a CLT panel.
Cross-laminated timber, or CLT, is an innovative new building material. It's made by gluing wood in perpendicular layers, creating super strong panels.
And what we're looking at doing is building a shelter for a tornado where you can go inside the shelter during the event and protect yourself from high winds. So just imagine that these are full-size 8-foot square panels. We're going to assemble this structure and have a roof on top that's going to protect us during the event. And one of the key things that when this tornado is blowing, we want to be inside there and make sure that it doesn't fail. And that means that it's got to be properly constructed with glues and adhesives, nails and screws to keep the thing assembled as a box to protect you. So we're going to focus today on different types of connectors and different types of adhesives that we could use to join this wood together. So we're going to learn how to glue together CLT panels using different types of glues and produce a test specimen that looks something like this, where we're going to look at what is the strength of that glue when we push down on this center piece to look at the shear capacity of the glue.
Wouldn't a brick house be better in a tornado than a cross-laminated timber panel? And why would a cross-laminated timber panel make a better shelter than a brick house?
Well, if you look at most brick houses, they use brick veneer for the exterior finish. So really you have brick veneer and then you have light frame wood construction behind that. So the brick is really not as strong as the solid panel is going to be to resist flying debris. So we're talking about a panel here that's 4 inches thickness of solid wood. And what we're trying to learn is how to glue this thing together to produce this solid, thick panel of just smaller pieces of timber. Before we get started here, I want to make sure that we're all protected. Give you some safety glasses. We've also got some earplugs that we'll need when we're operating some of the power equipment that produces a lot of noise.
It's very important to wear protective gear in the lab because you're not necessarily doing things that are very safe, and not wearing glasses could be a hazard to your health.
Better safe than sorry.
Okay, so each of you has these 3 blocks and then the longer block here. So you're going to align them like this to get them centered. And then you're each going to take the glue and put it on the cross section that's touching there. And then we're going to clamp these 3 together and let the glue set. Okay, so each of you has those. Why don't we start? You can have the regular glue. Justin, you can have the wood glue, and then Madeline, I'll give you the wood glue max.
The specimen we made was really cool. It was 2 wood blocks, and then it was 1 in the center, and we had to glue it together, and then we had to make another one where we actually screwed it together. That was pretty cool. I thought that was interesting. Power tools, yeah!
So if CLT is so strong, why don't we just construct our entire house out of it?
Well, CLT is a good material, but it is kind of expensive to produce. So you wouldn't want to build your whole house out of it. All we really need is a shelter where you and your family can go and wait out the hurricane or the tornado or whatever sort of storm it is that's passing by.
The engineers we met were pretty cool. They definitely were excited about what they were doing, and I think if you're going to be in any field, being excited about it and actually having a passion for it is one thing that you have to have. So I thought they were really cool people.
So why exactly did you want to be an engineer?
That's a good question. Growing up, I always played with toys like Legos and Kinects, and my dad loved it. My mom always tried to get me to play with dolls and stuff, but it just didn't really interest me as much. So growing up, I really liked math and science. It's what I understood. It's what I always did best at. And then when it came time for me to go to college and decide exactly what I wanted to do, it was between engineering and architecture for me. So I actually went to a few camps to where I learned about both of those majors. And I loved architecture, but it was a bit too artsy and very abstract. I love that in engineering, I see what I'm doing, I see how it applies, and it's very realistic.
Well, Kaylee talked about growing up that she played with Legos instead of dolls like her mom wanted her to, and I thought that was really cool because she broke the stereotypical girl can't be an engineer and can't do like a guy's, so to say, job, and she knew what she wanted to do, and I thought that was really cool. I played with Legos when I was little too, and I kind of feel the same way about the whole situation.
They're fun, aren't they?
I wanted to help people in my career, and I was thinking about being a doctor.
It's cool to be a doctor and things like that, but one thing that always stood out to me, like when I was taking my engineering classes, is engineers help build water treatment facilities and things like that. So as an engineer, you'll help all the people affected by that water treatment facility.
That water treatment plant is probably going to be there for a really long time. Like the buildings we design are going to be there for a really long time if they're built correctly, because they cost a lot of money. So you can help a lot of people for a really long time and really make a big difference.
Yeah, that's really cool. Being a doctor, you help one patient at a time. With engineering, it helps thousands of people in their everyday lives. And I think that's really cool because it's being able to see how you can apply engineering to everyday life.
All right, we're going to plane the lumber. It's important that when we glue it together that the surface is clean and really flat. So here's a piece of unplaned lumber. You can see as you feel it, it's sort of rough. And this is a piece of plain lumber. So what we're going to do is just run it back through this planer, and when it's done, this top surface will be as clean as this, and then we'll get ready to spread glue out on it and then put it into the press and actually produce one of those large CLT panels.
Noticing why they always wear earplugs because all the machines around here are very loud.
When the wood went in, it looked rough, and then when it came out, it looked smooth. I was like, whoa!
We're going to have quality glue. We need to make sure that we have the right amount of hardener and adhesive mixed together.
To get the whole glue system to work, we had to get it smooth and even and flat.
It was like spreading icing on a cake. It was very sticky. It went on really smoothly, and you could feel it starting to harden, especially on your gloves.
I got glue in my hair, so that happened.
Now that we've made our test specimens, we're going to test them. So we're going to test them using this device. It's a universal testing machine. And what we do is we're going to put this test specimen in there. And what we're going to do is apply a force on top of the test specimens until they break or fail.
So we're going to test the two specimens, one connection being glue and the other the connection being nails. So you'll notice when we put the glue connection down, when the force is applied to the top, you're not going to see any deformation before it fails, and that's because it's brittle. So when the force is applied, it's all of a sudden you're going to hear a pop and this piece is going to fall. Whereas with the nail connections, it's ductile. So when the force is applied, you're going to see it slowly start to sink as it's deforming before it fails. If you were in a house and failure was about to occur, which would you prefer?
Ductile.
That's right. So with ductile, you want to be able to see that it's deforming so that you can take the proper measures before it fails.
As you can see, there are many different tests that need to be done to determine the best way to protect people from inclement weather.
Like he built this like house out of like small wood panels, and we actually put it in the wind tunnel, and we tested it to see like how it would hold up. And now I see why the bonds have to be really important, because the wind was going like really fast, and it needed to hold up. So, and especially in a tornado or a hurricane, you want it to last and you want it to hold up. That was like really cool.
Now let's give these kids a taste of what they're up against by putting them in the wind tunnel.
We had boards that we were holding, and the pressure behind those like almost knocked you over. Going closer and closer, you felt your like ears and your face getting colder and colder, and it was just really fun.
How'd that wind feel?
Crazy.
Fun, insane.
Crazy.
How fast is that wind blowing?
85.
98.
Maybe 70?
Well, hard to believe, but that wind is only blowing about 35 miles an hour.
Oh my god.
You aren't
What?
I've never experienced anything like that, and the fact that it was only going 35 miles per hour was a huge shocker, because it felt like 100.
So can you imagine being in a hurricane with the wind's blowing 130 miles an hour, or worse, in a tornado and the wind's blowing like 200 miles per hour?
Now that the kids have checked out the wind tunnel, let's make our way to the cannon to test their panel's resistance to flying debris, the greatest danger during a high wind weather event.
Remember earlier today we fabricated that CLT panel? Well, now we're going to test it to see how impact resistant that panel is. All right, Justin, you ready to fire this missile? Mm-hmm. So this is the trigger. Just going to pull down that handle. So give us a countdown, and anytime you're ready.
3, 2, 1.
I'm sorry.
85 miles an hour.
That was 85 miles per hour.
It showed how like absolutely strong CLT is.
That'll leave a mark.
Well, today we're able to learn a lot about the CLT. We learned about impact resistance, of how to stop a 2x4 from traveling inside the shelter. We also talked about how we're going to connect these walls together to form this box. And then finally, we spent a little bit of time in the wind tunnel learning about wind loads on structures. So what do you think about today's experiments?
My favorite part of today, I think, was really meeting all the different engineers and the different students. It was really great to talk to them and get their take on things. That was really cool for me. I really liked being able to relate to them. It really brought what engineers do down to earth, and I really liked that.
You guys have a good time and learn something?
It was awesome.
Yeah.
I got a great perspective.
Well, are you ready to start designing your own shelters?
Yes.
So let's go do one.
It was just a really great experience. I found that each engineer was very passionate about what they wanted to do, and they knew from a very early age that this was what they wanted, and that just kind of stood out to me, and it showed me that maybe I want to be an engineer too.
All in all, I'm glad I got the chance to discover engineering.